9-3, we looked at how to use molarity in dimensional analysis, and doing titration calculations that involve mass is just an extension of this. You could also use this strategy when you're solving problems that don't involve mass, if you just like dimensional analysis better. But usually for simple one-to-one solution problems, the MAVA strategy is a little bit easier. But here we go, using mass in titrations. So question 1, how many grams of potassium hydrogen iodate, which has a molar mass of this, would be required to neutralize 25 milliliters of 0.1 molar sodium hydroxide? So if you remember from 9-3, anytime we're doing a dimensional analysis problem that involves multiple numbers, we pick the number that only has one unit. Our volume is the only thing that has one unit, because remember, every time you see molarity, you need to think that this is moles per liter, because that's going to be important when we plug it into our tracks. So we're starting with our 25 milliliters of NaOH. From there, we know we also need milliliters of NaOH down here. Then we're going to use our molarity. If it's moles per liter, we can also do it as moles per 1,000 milliliters of NaOH. You could do an extra step and explicitly change our milliliters into liters, but this is how I normally do it. So for every 1,000 milliliters, we have 0.1 moles of sodium hydroxide. Now we need our mole ratio. We need to know how these two things react with each other. And we could write out a balanced equation, and sometimes that's a good plan. But one thing you'll notice in titrations is a lot of the time we're using what's called monoprotic acids, especially in this year of chemistry, because anything with more than one H actually gets kind of weird. Monoprotic just means one H. This has one H. So if this has one H and this is one OH, my mole ratio is 1 mole of NaOH for every 1 mole of my acid. HA is just shorthand for big acid I don't feel like writing out. But it's got one H. That's the important part. And they were nice. They gave us a molar mass. So for every 1 mole of my acid, I know my molar mass is going to be 389.92 grams of acid. We've been doing this since Unit 6. Everything on the top we're going to multiply. We're going to divide by everything on the bottom. If you're going to use Desmos for this, and this is one where Desmos is okay. Also, if you've got access to an Inspire, the fancy divide makes your life easier because you can put everything on top. So we're going to have 25 times 0.1 times, I skipped the 1 because it doesn't do anything, 389.92 divided by 1,000, because that's my only number down there. And that gives me that I want to react 0.975, because remember, for Quest, if it's less than 1, you want to keep 3 decimal places. 3 actual numbers, though. If there was a 0, you'd start counting from there. Grams of, of my acid, because everything else canceled. All right, let's go back the other direction. When I titrate my sodium hydroxide solution with 1.25 grams of the acid, because apparently I weighed a little too much, it actually takes 35 milliliters of the sodium hydroxide solution to reach the endpoint. What is the molarity of this solution? And this is a lot of times what you're trying to do with a titration. You're trying to figure out what your molarity is. And these nice solid acids are a good way to do that. So we're going to start with our grams, because the 35 milliliters requires a molarity to do stoichiometry, and hey, guess what? We're looking for molarity. So we'll start with our grams of my acid. And then we know if I'm starting with grams, I need grams on the bottom, and anytime I'm not in moles, I have to get there. So it gave us our molar mass. Remember, mass goes with grams. The moles is always 1. The molar mass basically never is. And remember, if you aren't given this mass, you're looking at the periodic table. Big giant things like this, they tend to be nice and give you them. So I get to moles of acid. Again, we figured out earlier that it's a 1-to-1 ratio because I've only got one H, only got one OH. I can bring that down. I'm trying to calculate molarity. Hey, guess what? You can't really find molarity in your tracks. That is something you'll have to figure out outside. But I can find my moles of, and this is why copying and pasting is bad. Because, hey, guess what? Earlier, we were going the other way around. Check and make sure all your labels make sense. So I've gotten from my grams of acid to my moles of acid, from my moles of acid to my moles of sodium hydroxide. I want molarity. Remember that molarity is, from our 9-3 notes, moles over liters. So we'll bring that over from our 9-3 notes. Yes, we need to keep remembering things from earlier on. So I can get my moles and then calculate my molarity. So let's get our moles. Again, we're going to use the fancy divide. And we're going to multiply the things on top, which actually there's really not that much to multiply and divide in this because we had a lot of ones. So we got 1.25 grams divided by 389.92. I don't have very many moles. So my number of moles is 0.00321. This is what I mean by keep 3 numbers after the decimal place, not necessarily 3 decimal places, because Quest would get mad. That's my moles of NaOH. And for the sake of neatness, we're going to get rid of this column we didn't need. I know my moles. I know my volume. I can calculate molarity. So this solution contains 0.00321 moles of sodium hydroxide. For every weight, we've got to transfer our milliliters into liters, but we should know this by now. We're going to move our decimal place over 3 times. So 1, 2, 1. I can count. It's early. 1, 2, 3. So my number of liters is 0.035 liters. So now I divide. And here's another trick on Desmos. If you're using Desmos, use your answer button. So it'll bring my whole answer down. Then I can divide by my volume, which is 0.035. So it turns out my solution is actually slightly less concentrated than I expected. So the molarity of my solution ends up being 0.0916 molar. It's supposed to be 0.1. It's a little bit less than that. There's a lot of reasons for that. Hopefully now this makes a little bit more sense. So if you're given a volume and a molarity, you can go to grams. If you're given grams, you can get to moles, but not molarity yet. You could get to milliliters if you already knew your molarity. So follow your tracks, follow your units. Make sure you walk through what you got. Hopefully that helps a bit. If you've got any questions, please let us know.